Okay, so in this video, we're going to talk a little bit more about some graph and function attributes, and that's going to be what happens as x is going towards infinity, right? So if x is going towards infinity, then we can talk about the function and where it's approaching, right? And we can talk about x going to positive infinity or x going to negative infinity, right, with the little negative symbol out in front. Right. And all this means is that if I hop onto f of x and I head towards positive infinity for x, where is my function going? In this case, f of x seems to be approaching a value. Right? If I'm approaching x going to negative infinity, I can hop on my function and see where the function is going. And in this case as well, f of x happens to be going towards some value. We use this notation, x approaching infinity, to indicate the variable x approaching infinity, right? The notation x with the arrow in negative infinity indicates that the variable x is approaching negative infinity. The notation f of x with the arrow in c indicates the function f of x approaching a specific value c. And these can be written separately as x approaches infinity, f of x approaches c. Or they can be combined into a single notation that you'll see more commonly as you advance in your math courses, and that's the limit as x approaches infinity of f of x is equal to c. In either case, these are known as the end behaviors of a function, right? Those end behaviors are what the function approaches as x goes towards positive or negative infinity, okay? So what does that mean for us, right? Well, if x is approaching infinity, it is known as a right-hand behavior. Why? Because we're going to the right side of the function. If x is approaching negative infinity, it's known as the left-hand behavior. Why is that? Well, we go to the left side of the function and we're saying, where's the function going when I'm over there on the left side? Okay. The function could be approaching a particular value, or the function could be approaching some sort of infinity, right? So for example, on this particular graph, if x goes to infinity, then the function is heading towards negative infinity, right? Of course, the left-hand behavior here would be up towards positive infinity, right? To the left, positive infinity, but to the right, negative infinity, okay? Here, x is approaching a specific value, right, somewhere here in the middle, right? If it's talking about what's happening to the function in the middle, that's not the end behavior. The end behavior is what's happening on the far right end or on the far left end of the function, right? So here, this would not be an end behavior, right? But we can talk about this notation of where the function is going. In this case, from both sides, I happen to be going towards negative infinity, right? Once again, this notation, x approaches infinity, f of x approaches negative infinity, indicates that x approaches positive infinity, the function approaches negative infinity. We see that in this graph, right? F of x approaches infinity or f of x approaches negative infinity anywhere on the graph of the function, then the function would be unbounded, okay? And remember, this end behavior of a function is what the function approaches as x goes towards positive infinity or x goes to negative infinity. You must use the appropriate notation, okay? Once again, x to positive infinity, right end behavior. X to negative infinity, left end behavior. And really and truly for these end behaviors, right, x going towards infinity or towards negative infinity, there's only three possibilities. Either the function is approaching a value, or the function is going towards positive infinity, or the function is going towards negative infinity, okay? So that is working with end behaviors as one of our attributes of function. Be sure that you stay up with all the attributes of functions that we need you to be familiar with.